All right, today we're taking a deep dive into some serious hardware. We're looking at the Thor Broadcast H-1SDI-DVBT-IPLL Encoder Modulator.
That's a mouthful.
It is, yeah. But the key claim here, and this is from a bunch of tech specs and reports, is that it's the fastest encoder used for live video applications.
And that's a big claim.
It is. So our mission today for you, the listener, is to figure out why speed is suddenly everything in video distribution and what makes this little box so important.
Well, that speed claim points directly to a real need. At its core, this unit is basically a specialized bridge.
A bridge between what and what?
It takes a professional HD-SDI input, that super high-quality uncompressed feed from a studio camera, and it transforms it.
Into something we can actually watch.
Exactly. Into streamable formats like DVB-T or IPTV. It's the engine that gets that pristine video signal ready for the viewer.
Okay, let's unpack this speed thing. We hear low latency all the time, but how fast are we actually talking?
This is the interesting part.
The key feature they're pushing is 70 millisecond low latency encoding. The times are as low as 70 mirrors, maybe up to 250 mirrors.
Right.
To give us some perspective, what are we used to seeing? I mean, what makes 70 mirrors so special?
Well, typically older systems, or especially software-based encoders, they can introduce half a second, maybe even a full second of delay.
A full second. That's huge.
It's a catastrophe if you're dealing with live camera feeds. So 70 milliseconds is a massive leap. You see this in stadiums where the system is used.
How so?
That speed, that 70 milliseconds, means you can actually use the video feed from the Jumbotron as the audio reference for the stadium's PA system.
So you kill that awful.
You kill the echo, yeah. Where the sound you hear in the stands doesn't match the video you're seeing. It completely solves that.
That really grounds the claim. It's being called a game changer, but is a 70 millis solution really new? Or is the game-changing part that they've made it affordable?
It's definitely the latter. This kind of speed, it used to be reserved for incredibly expensive high-end broadcast hardware.
So this is about accessibility.
Exactly. This unit makes that ultra-fast distribution possible for, say, any headend or even a collegiate sports program. The fact that it's already in dozens of pro stadiums just shows it can handle it.
So the speed is for live events. Got it. But let's pivot a little. Once the video is processed that fast, how flexible is this unit? It's listed as an encoder, a modulator, and an IPTV server.
All at once?
Is that like 3 boxes crammed into one? What is each part doing?
It's a multi-tool, really. The encoder part compresses the raw SDI video. The modulator converts that signal so it can go over traditional RF cables, like for a cable system.
And the IPTV server.
That packages the data to stream it over a computer network. And the beauty is you control all 3 functions through a simple web page.
Oh, nice. So no complex software.
Nope. Just a standard web browser on port 80. It makes setup and management really, really simple.
Okay, that makes sense. But what about the outputs? I see it supports legacy MPEG-2 and modern H.264. Why would anyone still use MPEG-2?
Compatibility. It all comes down to compatibility. H.264 is way more efficient, but a lot of older cable systems or TVs in, say, a hospital, they only understand MPEG-2.
So you can serve both old and new screens from the same box.
Precisely. And you get a super flexible bit rate to play with. It goes from a tiny 0.5 MMAPs all the way up to 19 millips.
That's a huge range. So an integrator could run a low bandwidth feed for security cameras while sending a flawless 19 megabit feed to the VIP lounge TVs.
At the same time from the same box. And it can go anywhere. You have the RF outputs for cable, and you also have IPTV protocols like RTP and UDP for streaming over a network.
So it can send one stream to one device or broadcast to hundreds of screens at once.
You got it. Unicast and multicast. It covers all the bases.
So what's the big takeaway here? It seems like this Thor unit is a perfect blueprint for modern video infrastructure. It blends a high-end source, SDI, with all these different distribution methods, all while making speed the #1 priority.
Absolutely. They've pushed that latency down to 70 milliseconds, which for almost any live application today solves the delay problem. It raises a really interesting question, though.
It is.
The real question for engineers now isn't, can we reduce the delay? They've done that. The question is becoming, at what point does this stop being a hardware problem and start becoming purely a physics problem? That's the edge they're on now.